All right, so far we've been finding solutions to equations, and that's great. Now we're going to focus our attention on finding solutions to inequalities. Now, inequalities and equations are very, very similar in many ways. An inequality is anytime you have two expressions, but separated by an inequality sign. In this case, we have 3x minus 4 is less than or equal to negative 19. There's less than or equal to. There's also strictly less than. That looks like this. That means less than but not equal to. There's greater than or equal to. And there's also strictly greater than but not equal to. And we're going to see all of these different variations here. And a solution to an inequality is very similar to a solution to an equation. It's just any number or numbers that when you substitute it in for your variable or variables, it makes the, in this case, inequality true. So what I want you to do first is actually going to ask you to pause the video in a moment, and I want you to think of some solutions to this inequality. And I'll give you a hint right now. There's actually going to be more than one solution. And I'd also like you to come up with some non-solutions. So pause the video and try that right now. Okay, we could really go ad nauseum here. There are a lot of solutions. I think one that a lot of people come up with is -5, for instance. -5 is one solution. That's going to be very important in this case. -6 also works. -100 also works. -31.2 also works. And as you can imagine, these really do go on for a while. There are a lot of solutions. In fact, there are going to be infinitely many solutions. Listing them forever and ever, actually not a very good use of our time. Important that we come up with some non-solutions as well, which I'll just do in red for non-solutions. 0 is not a solution to this. -2 is not a solution to this. 4 is not a solution to this. +100 is not a solution. There are actually also going to be infinitely many non-solutions as well. So this is one big difference between inequalities and equations. Equations so far have usually had one solution. Here we have infinitely many. And so what we're going to do is we're going to actually have to come up with a new way of explaining what's called the solution set here, the set of all solutions to this particular inequality. Now the steps for solving an inequality are almost the exact same as the steps for solving a solution. Solving an equation. And so let's go through the motions here. There is going to be a big difference, and I'll show that to you in the next example. So what I think I want to do here is, first things first, let's add 4 to both sides of the inequality. So we end up with, let's see, 3x is less than or equal to -15. Let's multiply both sides of the inequality by 1/3, and we end up with, pardon me, let's see, x is less than or equal to -5. So it appears to me that if we wanted to talk about all the solutions to this inequality, we found some using intuition, but here is the formal statement of our solution set, that all numbers less than or equal to -5, those are the numbers that are going to make this inequality true. -5, -5.1, -5.2, -6, -7, -8, all the way forever and ever. And when we're looking for solutions to an inequality, we give our reader two things. One, a formal statement of the solution set. That's what we just did, right, like that. We also like to give them a picture or a graph of the solution set. Now, how do we do it? -5 in this case is a very special number. It's actually the number that makes the left expression here equal to the right expression. We call it a boundary number. That's what I like to call it. And so what we're going to do is we're going to write -5 on our number line, and we're going to put a closed circle in it, a filled-in circle, meaning -5 is a solution. It's part of the solution set. And we're looking for all numbers less than -5. And that means all numbers to the left of -5 on the number line. So what we're going to do is we're going to shade it just like this. And sometimes I like to put a little additional arrow there, just to tell the reader, yes, this goes on forever and ever and ever. So this is a visual graph of our solution set. So whenever we have an inequality, we like to give a formal statement of the solution set and a graph. One little note. If the inequality had instead been 3x minus 4 is strictly less than but not equal to -19, things would have been almost the same. Our solution set would have been x is strictly less than -5. And the graph would look almost the same. At -5, our boundary number, we would have what's called an open circle at -5, showing the reader that -5 is not part of the solution set, but all of these numbers going infinitely close to -5 are. So one little note between closed circles that go with less than or equal to, or greater than or equal to, and open circles, which go with less than or just greater than. All right. I told you there was one key difference to finding the solution set for inequalities as opposed to equations. Again, take a moment here. I'd love for you to think of just one or two solutions and one or two non-solutions to this inequality right now. All right, so obviously there are infinitely many solutions and infinitely many non-solutions, but I just came up with a couple here where I just did a little guess and check and Some of these worked and some of these didn't work. I gotta say, my favorite number to try out is often 0. Really easy to test out when you substitute in 0. So this is gonna be the one time when something happens that's a little different than solving equations. Like before, I think the first thing I'd like to do here is add -3 to both sides of this inequality. Go ahead and add -3. And now we end up with, let's see, -2x is less than or equal to 6. Now, I can imagine that, the next step we often would like to do here is multiplying both sides of the inequality by -1/2. Multiply by -1/2. Now, we know that in our final step, we're going to have x and we're going to have -3 here. Now, we might think that the solution set is just going to be x is less than or equal to -3, right? Why not? But actually, we've already seen through some of our intuitive examples that, wait a second, x is less than or equal to -3. That can't possibly be the solution set because all of these numbers are not solutions and they're less than or equal to -3. And these numbers are. In fact, if we just take a look right here, -2x is less than or equal to 6, you'll see that the numbers that make that statement true are actually all numbers greater than or equal to -3. So the big thing to keep in mind is that, here we go, here's the note on the bottom of the screen. Whenever you're solving an inequality and you multiply or divide both sides of the inequality by a negative number, you need to change the direction of the inequality sign in order for it to stay true. You must flip the direction of that sign. That is so important. So in this case, our statement of the solution set is going to be x is greater than or equal to -3. And you know how to graph this, right? We're going to have -3 as our boundary number. It's going to be a closed circle, and we are going to shade to the right. And you can put a little arrow there to let the reader know it goes on and on forever and ever. Super big deal though, right? When we multiply both sides by a negative number, we have to flip the direction of the inequality sign. Now note, got to be careful. I'm going back to the first example for a second. Note that in our first example, we had a negative number of sorts, but we never multiplied or divided both sides of the inequality by a negative number. So there was no need to flip the direction of this inequality at all, right? Only in this second example. And you know what you can do? You can always test some numbers to make sure you didn't mess up and forget to flip it or accidentally flipped it when you didn't need to. One last example here. All right. Now we can see this is a pretty complicated inequality going on here, but we're going to solve it using the exact same strategy that we had before. First thing first, I think it's a good idea to simplify both sides of this inequality. Well, in this case, the right-hand side, there's some distribution going on. We can collect some like terms. All right, let's do it. So I think one thing I'd like to do is let's go ahead and distribute this 5. So we've got 4x minus 10x plus 10 plus 12. All right, -3x plus 4. All right, let's see what we got going on the right-hand side. I'm going to collect these two guys right here. We've got -6x, and we've got plus 22. All right, now we've got some options here. We could add 6x to both sides of the inequality. We could add 3x to both sides of the inequality. We got lots of options. I'm going to show you something here that's going to help highlight a potential misconception. So I'm going to go ahead and add 3x to both sides of the inequality. What's great about that is now we're going to have no more of that unknown on the left side and only on the right side, and that's great. All right, so now we've got, let's see, 4 is less than or equal to -3x plus 22. I'm going to go ahead and add -22 to both sides. Let me make sure that's clear. Okay, adding -22, and we end up with, let's see, -18 is less than or equal to -3x. Okay, immediately I see, wait a second, I'm going to be multiplying by a negative number here. All right, you know what I like to do? I immediately remind myself to change the direction of that inequality, just so that I don't forget. -1/3, fantastic. So we end up with, let's see what, 6 is greater than or equal to x. One thing that's different about this example, one, it was good to remind ourselves about how we have to flip the direction of the inequality if we multiply both sides by a negative number. But usually we're used to having the variable on the left-hand side. But in this case, we have the variable on the right-hand side. Is that a big deal? No, totally fine. But sometimes folks get a little messed up. They think that the direction of this inequality immediately means that the arrow is going to go to the right. But that's not the case here, right? This means 6 is greater than x, which is the same as saying x is less than or equal to 6. One thing I sometimes like to do is if I end up with my solution being such that my variable's on the right, sometimes I like to rewrite it so my variable's on the left. One, it's just more natural. And then yes, if the variable's on the left, the direction of that arrow is going to be the direction of your arrow. So the statement of the solution set here is x is less than or equal to 6. Our graph of the solution set is here 6, closed circle, shading to the left, and maybe putting in a little arrow there. So that's how we solve and represent the often infinitely many solutions to these inequalities.